Day 409 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 410, split array largest sum. The difficulty level is hard, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. Given an integer array nums and an integer k, split nums into k non-empty subarrays such that the largest sum of any subarray is minimized. Return the minimized largest sum of the split. A subarray is a contiguous part of the array. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we're doing this problem correctly. So in example 1, we have the input nums equals the array of integers 7, 2, 5, 10, and 8. The k equals 2. The output is 18. The explanation says there are 4 ways to split nums into 2 subarrays. The best way to split it is into an array of integers 7, 2, 5 and an array of integers 10 and 8 where the largest sum among the 2 subarrays is only 18. So even then it can still be a little bit tricky to understand. So let's come over here so I could give y'all a better visual representation of what's going on, right? So say we do our first split and we just split it right here and we have a subarray of 7 and then we have a subarray of 2, 5, 10, and 8 like we do over here. Boom, right? In this case, this subarray has a sum of 7, but this subarray right here has a sum of 25. And since 25 is the largest of the 2 sums, we're gonna include the largest, or 25, in our calculations when we're looking for the largest sum, the minimized largest sum. So in this case, the largest sum is 25 when we split it like this. Boom. Then we can split it right here with the 7 and 2, right? Like we did over here. 7 and 2, or 5, and then 5, 10, and 8. In this case, 7 and 2 has a sum of 9. 5, 10, and 8 has a sum of 23. 23 is greater than 9, so 23 is the largest sum of this if we split it like this. So we could come over here and put 23 because that has the largest sum when we split this subarray. Boom. Then, and it's important to remember, k equals 2. That's why we're only splitting it into 2 subarrays, but k could equal anything. K could be 3, it could be 4, it could be 1. It's just in these 2 examples it's 2, so we only had to split it into 2 subarrays. But we need to remember that k can be anything. K will not always be 2. We need to remember that when we're writing our code. Now let's get back over here, right? So we could split it like this with 7, 2, 5 as one subarray, and then 10 and 8 as another subarray like we did over here. Boom. If we split it like this, then this subarray has a sum of 14. This has a this subarray has a sum of 18. Since 18 is greater than 14, then we're going to include that in our calculation. And right now, so 18 has the largest sum of the subarray. And this, if we split it like this. If we split it like this, 7, 2, 5, 10, and 8, right? So this is one subarray. This subarray has a sum of 24. This subarray has a sum of 8. So since 24 is greater than 8, the largest subarray, or the largest sum, or the subarray with the largest sum has a sum of 24. Now we have all of our largest sums calculated from each subarray that we created, but this is where we want to minimize it. We want the smallest largest sum that we have created out of all of these splits, and in this case 18 is the smallest largest sum that we've created, right? Because 18 is less than 25, it's less than 23, and it's less than 24. That's why our output is 18, and that's what they mean by we want the minimized largest sum. Out of all of the largest sums that we found, 18 is the smallest, and that's why 18 is the output. So I hope that made sense to y'all, but let's go ahead and keep on going and take a look at example 2. So in example 2, we have the Input nums equals an array of integers 1, 2, 3, 4, and 5. This time k equals 2. The output is 9. Explanation says there are only 4 ways to split the nums into 2 subarrays. The best way to split it is into 1, 2, 3, and 4, and 5, where the largest sum among the 2 is only 9. So I'm not going to go through this whole example like I did last time, but it's the same principles apply. We split it into 2 groups. We could split it like this, we could split it like this, we could split it like this, or we could split it like this. Those are the 4 ways that we can split it, right? And in this case, the best way to split it is like this, with the 1, 2, 3, and the 4, 5. In this case, that'll have this will have a sum of 9, which will be the smallest, largest sum that we can create. As you can see, this right here has a sum of 6, which means 9 is the largest sum when we split it like that. And out of all the ways that we could split up or split this array into subarrays, 9 will be the largest sum of the subarray, or the smallest largest sum of the subarrays that we were able to create. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution, y'all. Now, the first thing we're going to do with this solution is we're going to create a helper function to check if we split nums into k subarrays, where each subarray has a sum that is less than or equal to a split sum, which is what we're going to create. So for that, we are going to say private func is valid. Then we're going to, or we could say is valid split sum. Then we're going to open up the, or no, not open up the brackets yet. We're going to open up the parentheses, and we're going to say underscore nums, colon, that's going to be an integer. Then we're going to say comma, or excuse me, nums is going to be an array of integers, come outside of that array. Then we're going to say comma. Then we're going to say underscore a split sum. Then we're going to say colon, and that's going to be an integer. Then we're going to come and say comma. Then we're going to say underscore k colon, and that's going to be an integer as well. Then we're going to return a boolean. So we'll say bool, just like that. Now we are going to create a variable in where the index in num splits is the number of subarrays formed. So we're going to declare a variable I and splits. Sorry about that, y'all. So declare a variable I and splits. We're going to set I equal to 0. And then splits is going to be equal to 0 as well. And once again, splits is going to be the number of subarrays that we have formed, and I is going to be the index in nums. Then we're going to try to build one subarray without exceeding the a split sum that we did right here. So for that, we are going to say, first we're going to sorry about that, y'all. First, we're going to start our while loop. We're going to say while I is less than nums.count. We're going to open up the brackets, and we're going to declare a variable called sum and set that equal to 0. Then we're going to try to build a subarray without exceeding the a split sum. So for that, we're going to say while I is less than nums.count and sum plus nums square bracket I is less than or equal to a split sum. Then we're going to open up the brackets. Then we could say sum plus equals nums square bracket I, come underneath that, and we could say I plus equals 1. Boom. Now, after building one subarray, we're going to increase the split count. So we'll come right here and we'll say splits plus equals 1. Boom. Then we're going to come underneath that, and if the number of splits needed is less than or equal to k, then a split sum is a valid choice. So we're going to come right here and we're going to say return splits less than or equal to k. Boom. Now we can't run it yet because that's just the helper function. Now we need to get into the main function. Now for the main function, first thing we need to do is we're going to be using some binary search. So we need to initialize our binary search bounds. So for that, we can say declare variable called left. We'll set that equal to 0. We'll say comma. Then we can say right, set that equal to 0 as well. Now we need to make it so left is the largest single element in the array, which will be the minimum possible max subarray sum, and right is the total sum of the array, which will be the maximum possible max subarray sum. So for that, we could say for num and nums, we're going to open up the brackets and we're going to say left equals max, open up the parentheses, num, comma, left. And that's going to get us the largest single element in the array. Boom. Then we're going to come right here and we're going to say right plus equals num. And that is going to get us the total sum of the array. And the answer cannot be more than the sum of the entire array. Then we're going to initialize the result with the maximum int value, and our result is that's what's going to store our output. So we come right here, we could declare a variable called result, and we could just set that to int.max just to start. That's just our default value to start. Now we need a binary search over the range left and right. So for that, start our binary search loop. We'll say while left is less than or equal to right. Then we're going to open up our brackets. And we're going to, first thing we need to do is we need to find a midpoint. So we're going to say let mid equal left plus right. And then we need to, we could do it like this to avoid overflow. We're going to say left plus open up the parentheses, right minus left, and then we're going to divide that by 2. And once again, that's going to help us prevent any overflow. Boom. Then we come underneath that and we need to check if it's possible to split the array into at most k parts with the max sum being less than or equal to mid. So for that, this is what we're going to call our helper function. We're going to say if is valid split sum. Then we're going to open up the parentheses. We're going to say num, comma, mid, comma, k. We're going to come over here. We're going to open up the brackets. Then we need to update the result with a smaller valid maximum sum. So we could say result equals the min, open up the parentheses, result, comma, mid. Boom. Then we come underneath that. We say right equals mid minus 1. So we're going to try to find the smaller max sum of the left half. Then we could say otherwise we need to search the right half for a larger valid sum. So we could say come right here and we could say else left equals mid plus 1. Boom. Now we just need to return the smallest valid maximum subarray. So to do that, we could just return our result by saying, sorry y'all, return result, just like that. Now that should be all she wrote, y'all. Let's go ahead and give it a run, make sure it runs like it's supposed to. Okay, and we have an error, cannot find num and scope. Sorry y'all, so this should be nums from right up here. Boom. So now let's give it a run. See if that runs, see if that works. Okay, cannot find splits and scope. Where we got splits at? Splits. So that should be Sorry, y'all. We could just add an S to this, or take away the S from that. Either one, whichever one you want to do. Now let's go ahead and give it a run. And it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. Those are the numbers that I like to see. So with that being said, y'all, I hope you learned something today. And I hope, or before we go, though, make sure you get one more look at the code so you can see everything. This is the top part of the code. Boom. This is the middle part of the code. Boom, and this is the bottom part of the code. So yeah, with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.